Hello friends, my name is Abhishek Srivastava. Today we are going to do the questions of dimensional analysis of class 11 of subject physics. So we are proceeding with the questions. So here is the question. F is equal to mv square by r. This is the formula of the centripetal force. We have to derive it with the help of dimensional analysis. So we are proceeding with the question. So F is the force that is being applied. So it is directly proportional to the parameters of this formula that are mass and raised to a constant that is A, velocity V raised to a constant that is B, R raised to a constant that is C. So now for proportionality we are taking a constant that is K. So it becomes equal to, so F equal to K M raised to power A, V raised to power B, R raised to power C. This is our first equation. I think you all might have understood this much. So now we are writing the formulas in terms of dimensions or the dimensional formulas of each values on both sides. So here it is force, that is mass, which is represented by capital M, acceleration, that is LT raised to power minus 2 enclosed in a square bracket, so is equal to K times the dimension of M is, mass is capital M raised to the exponential power that is A, velocity that is length T raised to power minus 1 whole raised to power the constant B, and the radius that is the length, so it is represented by capital L in terms of dimensional analysis or in terms of dimensions raised to power C. So I think you might have understood this much. This is our second equation. So now we are comparing the dimensions of M, L, T on both sides. So comparing the dimensions of M, so here the dimension on the left side is 1, the dimensions on the right side is A. So the value of A is 1. This is our third equation. You all might have understood this much. Comparing the dimensions of L on both sides. So here the dimension is 1. Here the dimension is L multiplied by B, that is B, and L into C, that is C. So it is B plus C. 1 is equal to B plus C. This is our fourth equation. Now comparing the dimensions of T on both sides. On the left side it is minus 2. On the right side it is minus B. So now minus sign gets cancelled from both sides, so B is equal to 2. So the value of B is 2, A is 1, and substituting the values in the equation 4, we get 1 is equal to 2 plus C. So the value of C is 1 minus 2, that is minus 1. So the value of C is minus 1. So we have found the values of A, B and C. So substituting these values in the equation first, we get f is equal to m raised to power 1, v raised to power 2, r raised to power minus 1. And for simplicity, we are taking the value of k as 1. So the formula becomes, arranging, we get f is equal to mv square by r. I think you all might have understood this question. This is the derivation of the centripetal force acting on a body when it is moving on a circular path with the help of dimensional analysis. So we are going to understand this question once more. The question given to us is, we have to derive this formula f is equal to mv square by r, where f is the centripetal force of a body which is performing a circular motion on a circular track. So here it is mv square by r. It depends upon the parameters m, that is mass, v velocity, and the radius of the circular path, that is r. So our first equation according to dimensional analysis becomes f is directly proportional to m raised to power a, v raised to power b, r raised to power c. So for proportionality, we are taking constant, that is k, so it becomes equal to, so f is equal to k m raised to power a, v raised to power b, r raised to power c. So this is our first equation. I think you all might have understood this much. So now we are writing the formulas of each parameter on both sides in terms of dimensions. So force, according to Newton's second law, it is mass into acceleration. So the dimension of mass, that is m, capital M, and acceleration is mt raised to power minus 2. Here equal to k, and the dimension of m is capital M raised to power a. Velocity, that is L t raised to power minus 1 whole raised to power b. R, that is the radius, that is the length. So L raised to power c. This is our second equation. So now we are comparing the dimensions of m, l, and t on both sides. So comparing the dimensions of m, we get on the left hand side it is 1. On the right hand side it is a. So 1 is equal to a. Or in other words, a is equal to 1. The value of a, constant a, is 1. Now we are comparing the dimensions of L on both sides. So the dimension of L on the left hand side is 1. The dimension on the right hand side is L, and it is multiplied by this exponential power, that is b, 1 into b, that is b, and L, there is another term L, that is also having a constant exponential power c. So the exponential parts will be added, so it becomes b plus c. So 1 is equal to b plus c. This becomes our equation 4. Now comparing the dimensions of t on both sides. So here on the left hand side, the dimension of t is minus 2. On the right hand side, it is minus 1 and multiplied by b. That is the exponential power, that is becomes minus b. So minus 2 is equal to minus b. Minus sign gets cancelled from both sides. So the value becomes b is equal to 2. So the value of the constant b is 2. Now substituting the value of b from in equation 4. So it becomes 1 is equal to 2 plus c. So c, this 2 comes on the other side, becomes minus 2. So it is 1 minus 2, that is minus 1. So c, the value of c is minus 1. So we have found the values of all the constants, that is a, b, and c. So now we are substituting these values in equation first. That is f is equal to k, m raised to power a, v raised to power b, r raised to power c. Substituting the values of A, B and C. So we get f is equal to k m raised to power 1, v raised to power 2, r raised to power minus 1. Here the constant, for simplicity, its value is 1. So we are taking k is equal to 1. And arranging this formula, it becomes f is equal to mv square by r. And this is the formula that we have to derive. So I think you all might have understood this question. So we are proceeding to the next question. So I'm rubbing the board. So another type of question that comes in exams is, suppose this is our first equation. V is equal to u plus at. This is the first equation of motion. And we have to find, suppose v is equal to, there is an unknown parameter that is x plus at. So suppose this is the question that is given to us and we have to find this unknown constant, unknown variable or the parameter, and also we have to find what quantity it is. So here, according to dimensions, the dimensions of each term are equal. If there is a valid equation, so this is our valid equation, we are given a valid equation, and here we are using, according to dimensions, the dimensions of each term will be equal. So the dimension of velocity here, dimension of velocity v equal to dimension of x, that is the unknown parameter that we have to find. So writing the dimensions of v, that is lt raised to power minus 1, that is the velocity, and that is equal to x. So our unknown parameter becomes equal to lt raised to power minus 1, and this is the dimension of the velocity. So x is also a velocity, but it will be, according to this equation, it will be the initial velocity u, therefore it is the initial velocity. So this is our answer. So I think you all might have understood this question. So we are going to understand this question once more. We are given the equation v is equal to x plus at, which is a valid equation and it is following the laws of dimensions. So according to the rule of the dimensions, the dimension of each term is equal. So the dimension of the velocity, that is v, is equal to dimension of the unknown parameter, that is x. We have to find the dimension of the unknown parameter x. So comparing the dimensions or equating it, it becomes equal to lt raised to power minus 1. That is the dimension of x, and the dimension of x corresponds to velocity, so it is velocity. And here, according to this equation, it is the initial velocity u. So this is the unknown parameter, that is velocity, which is the initial velocity v, initial velocity u, and having the dimension lt raised to power minus 1. So I think you all might have understood this question. So please watch this video till the end, subscribe me and press the bell icon. Thank you.